We are asked to determine whether the following production functions represent increasing, decreasing, or constant returns to scale. So I have four production functions here. Now, when we talk about returns to scale, what we mean is when we increase the inputs to our production function. So when we increase our labor and our capital, does the output increase by the same amount or does it increase by more or less? So let's consider this first production function here. We have Q, the quantity, is equal to 3L plus 2K, where L is our labor and K is our capital. Now imagine that we double the inputs for both labor and capital. So in other words, we have Q is equal to 3. Instead of multiplying it by L, we're saying let's double that. So let's use 2L. Plus, and let's do the same thing with capital. So we have 2 times, instead of K, let's do 2K, so double the amount of K. Now what we'll notice is that in both of these terms, we can factor out a 2. So if we do that, we get 2 times, we would be left with 3L plus 2K. Now notice that this quantity right here, 3L plus 2K, this is the same as our original production function. So when we double our inputs for labor and capital, what we end up with is 2 times the original quantity. In other words, when we doubled our inputs, we exactly doubled our outputs. So we ended up with 2 times this original Q. So because we doubled our inputs and we exactly doubled our output, we would say that this production function represents constant returns to scale. Okay, now let's check out our second example here. We have the production function Q equals 4K squared plus L squared. So again, let's imagine that we double the input. So let's double the capital and double the labor. So here's what that would look like. Q is equal to 4 times, instead of K squared, we're going to say 2K squared. So we're taking double the amount of capital. Plus, instead of L squared, we'll do 2L squared. Now, if we simplify a little bit, when we have this quantity squared, we have to square both values in the parentheses. So we have to take 2 squared, which is 4, and K squared, which is just K squared. So we end up with 4 times, we have 4K squared, plus we have to do the same thing in these parentheses. So we'll do 2 squared, which is 4, and L squared, which is just L squared. So we have 4L squared. Now we'll notice that we can factor out a 4 out of both of these expressions. So when we do that, we get 4 times, we're left with 4K squared, plus when we factor out a 4 right here, we're just left with L squared. So notice that this quantity right here, this is equal to the original Q, the original production function. So notice what happened here. We doubled our inputs, but we quadrupled our output. So we had 4 times the original quantity. So because our output increased by more than our input, we would say that this is increasing returns to scale. All right, now let's check out example number 3. We have Q equals 3 times L times K squared. So again, let's imagine that we double our labor and we double our capital. So we double our inputs. Here's what we would get. Q is equal to 3 times, instead of L, we're saying 2L. So we're doubling the labor. And instead of K, we'll say 2K. So we're 2K squared. So if we simplify a little bit, we get 3 times 2L times this 2K squared. This becomes 2 squared, which is 4, and this becomes K squared, which is just K squared. So we have 4K squared. Now notice if we multiply our coefficients, we have 3 times 2 times 4. 3 times 2 is 6, times 4 is 24. So this is really 24 times LK squared. Now let's see if we can factor out a value to get our original production function of 3LK squared. Notice if we factored out an 8, that would be 8 times 3LK squared, because 8 times 3 is the same as 24. So now notice what we have. Here, this 3LK squared, this is our original production function. So we can see that when we doubled the inputs, we got 8 times the original production function. So we doubled our inputs, but we got 8 times the output. So again, this one is an example of increasing returns to scale. The change in the output is greater than the change in the input. So we'll say increasing returns to scale for that one. Now let's consider our very last production function. We have Q equals K to the 1/3 times L to the 1/3. Now imagine that we double both the input for the capital and the labor. So that would be Q is equal to, instead of K to the 1/3, we'll have 2K to the 1/3. And instead of L, we'll have 2L to the 1/3. So when we simplify this a little bit, we get 2 to the 1/3 times k to the 1/3. So let's write that. 2 to the 1/3 times k to the 1/3. And then we'll have 2 to the 1/3 times L to the 1/3. So 2 to the 1/3 times L to the 1/3. Now when we have 2 to the 1/3 times 2 to the 1/3, we can just add the exponents here. So 1/3 plus 1/3 is 2/3. So really this is 2 to the 2/3 times k to the 1/3 times L to the 1/3. Now notice what we have here. This is our original production function. So k to the 1/3 times L to the 1/3. And our coefficient is 2 to the 2/3. So if you punch in 2 to the 2/3 into a calculator, that comes out to about 1.587. So 1.587 times k to the 1/3 times L to the 1/3. So this time, when we doubled our inputs for both capital and labor, we ended up with 1.587 times our original quantity. So notice that this time when we doubled our input, we didn't quite double our output. We only multiplied the output by 1.587. So because this number is less than 2, it's less than doubling, this means this production function exhibits decreasing returns to scale. So when we doubled our input, we less than doubled our output. Now, one last thing that I want to mention is that examples 3 and 4, these are examples of Cobb-Douglas production functions, which take on the following format. Q is equal to A, where A is just some coefficient, times K to the alpha times L to the beta. So remember, K is our capital and L is our labor. When we have a production function in this format, all you have to do to figure out if the production function represents increasing, decreasing, or constant returns to scale is add the exponents. And if the exponents are equal to 1, then that means the production function has constant returns to scale. But if you add these two exponents and they're less than 1, that means they have decreasing returns to scale. And lastly, if you add the exponents and they're greater than 1, then that means the production function has increasing returns to scale. So for example number 3, we can imagine that this L has an exponent of 1. So the two exponents are 1 plus 2, which is 3. 3 is greater than 1, so that means this production function has increasing returns to scale, which is exactly what we found. And in example number 4, we can see that our exponents are 1/3 plus 1/3, which is 2/3. And that's less than 1, so that means this production function has decreasing returns to scale, which is also what we found. So that's just a little shortcut that you can use if you happen to encounter a Cobb-Douglas production function.